Today, we're going to start on a new topic. I hope that you guys have gotten ready all your color pens. Today, we need a lot of color pens, a lot of highlighters. We need even your, what's the thingy called? The compass to draw circles, okay? So you need all this equipment. Get ready all your equipment, your color pens, and the matching pens, color highlighters and matching pens. Then you need your compass, okay? So the heading is called circles. All right, circles. And these circles, for you all, no problem because you all don't learn emath. So just put emath. What happened now? Why is it like that? Okay, so this is emath circles. So you all can on the light in the middle. Now for circles, please take note that we have a few fundamentals that you need to remember. So next time when I say, whenever you see circles, right, what must come to your mind? Okay, guys? So you need to tell me what must come to your mind. So you might say, oh, Miss Lin, the fundamental of circles is what? What do you need about the two key things about circles that you learned in primary school? Very good, radius. But before radius, you need somebody first. No. That's even worse. Very good. The center. The center is what determines your circle. Because you need the center, then you can draw a circle, isn't it? Correct? You need a center. The fundamental is always about finding the center. And then the next one, the next fundamental is about your radius. And I don't want anyone to make notes. I just want you to listen first. Listen properly, okay, and understand the fundamentals, then you make notes. Now, when it comes to radius, guys, please be very, very careful. So I highlighted it in pink. Now, why is the radius very important? So, how do you know where the radius is located? How do you know where the radius is located, guys? Very good. So the radius is located from the center to circumference. Correct? So very good. You remember all your primary school one. So this is a radius. Now, one more thing that I want you all to take note that is very important when it comes to circle is that whenever you identify radius, right? You need what, guys? Who remembers? Or who knows? How to when you identify radius, you need something. What do you notice about radius in a circle? What about radius in a circle? What about this radius compared to this radius? Compared to this radius. What do you notice about all these radius? Very good. All the same. So how to show something that is all the same? Because you know that radius are all the same. So how do you show something that is all the same? What do you have to do? How do you show that something is all the same? What did I tell you guys before? Let's say you have to show something is all the same. What do you have to do? Hmm? Hmm? You have to do something to indicate that it's the same. What do you have to do to indicate that this radius is the same as this radius is the same as this radius? Yeah, you have to draw the tiny line. Very good. Looks like Hong Yun, today is your day. So right now, if I have a circle and this is my center, this is called a what, guys? Radius. This is called a... Then what do I have to do? I have to draw tiny lines, right? So I need to draw a tiny line here and tiny line here. Correct or not? So what do you notice already? This becomes a what, guys? Very good. Isosceles appear. Do you all understand now? Clear so far? So the reason why I go through so slowly on this is because a lot of students never draw tiny lines. Then when you don't draw tiny line, you cannot see isosceles, and then you cannot find the angle. Understand, guys? Now you all can copy. I give you some time to copy. And don't forget to follow the color coding. So here is all in purple. Purple, purple, purple. Okay, then this is in pink, but this one is not showing. By right, it's supposed to be pink. All these are all in pink. Don't know why it looks like red. It's supposed to be pink. Okay, all these are all pink. Then this is also in pink, in pink, in pink. Then after that, the other color, you know, is quite obvious. It's called green. So here, purple and pink. So this is the fundamentals of circles. Once you understand the fundamentals of circle, I'll go through the next fundamental. So write my black pen first. So this is under fundamental number 1. Next, I'll go through fundamental number 2. The next fundamental you need to understand is this very important word. Is the location. Okay, so what do I mean by location? So guys, I try not to copy because this is quite raw in my brain also. I'm trying to recall the mistakes that students made and I might edit along the way, okay? So that's why I highly recommend you all don't copy first until I go through, because right now I'm also recapping what common mistakes students make. Now, remember just now you told me another keyword that someone mentioned is a diameter, correct or not? So what is something that you learn about diameter? Diameter is equal to what? What about diameter? Diameter is equal to what? Radius times 2, right? So let's say, for example, guys, I have one radius here and another radius here. Can you see this radius? 2 radius? Is that a diameter? Why? How do you know what is considered a diameter? How come this is not a diameter? Why? How do you define a diameter? Cut through the whole circle, meaning this is also straight line. Perpendicular straight line. So perpendicular straight line is like that. Perpendicular straight line, that is a diameter.
Straight line that goes through.
Okay, I hear keywords, yes. Again. So this is also not a diameter. You say that it is a what? A straight line that goes through the center. But this also goes through the center. But why? What do you notice? It goes from one what? The circumference to the, cut through the center and go through another circumference, correct? And cuts the circle into 2 equal halves. Understand? So now, why I say location is very important. So just now, someone mentioned a keyword. What is the keyword? The new location that we realize. So we have location like center. What else that we need to take note of? What other location did we mention just now, huh? Very good, circumference. Okay, now why? Why center and circumference is very important. Later, I'll explain to you why. All right, so I'll give you guys some time to write first. So all this no need. So just write down location, center, and circumference. Okay, so right now, everybody take out your highlighter. We're going to learn this thing called angle properties. I highly recommend you don't write on this page. You write on the second page. These angles properties, right, is going to be a lot. Okay, a lot of angle properties. So you need one full page of angles property. Write it really big because now we are only focusing on angle. Later, we'll be talking about length. All right? So now we're only focusing on angle properties. Later, we'll talk about length. So right now, guys, please take note that you need to memorize the reasoning. So those in red, you must memorize the reasoning in red. So later, all those that we write in red, I hope that you all have your red pen, is everything you need to memorize and you need to write. Okay? Because if you don't do that, your teacher will penalize you. So you need to make sure that you do it step by step. So I love this topic. This topic is very fun and easy to solve. But I do not like marking because there are so many variations. Different students have different ways of doing. It's no one set answer. Okay? And I'm very, very particular about the flow of thoughts. So I hope that you all listen very carefully on how to do the proper steps. Okay, so remember to get ready your red pen. Now we're going to do a lot of reasonings. Now, the first one that I'm going to teach you guys, okay, it's something to do with this keyword called radius. So this is the first one. Number one. Okay, I don't write like that. I write like this. Number one, okay? I think I should teach your radius. Yes, radius. Now, please take note that next time I ask you, hey guys, when you see radius, what comes to your mind? You must tell me that radius good friend is tangent. Okay? And what is the angle property? Is that we can use this is, now some school teacher allow you to do shortcut. Some school teacher want you to spell out. So you have to listen to your school teacher. Because all of you, even though like the three of you guys, right, you are from the same school, you might have different way of doing also. Both of you are in the same class, right? Wait, you in the same class with Alyssa, right? Yeah, both of you are in the same class. Maybe your teacher will teach you a different way from Cass' teacher. Cass, your teacher, is it the same as theirs? Yeah. So maybe Cass, even though she's in the same school, her teacher said that, oh, it's fine to write a symbol. But then for both of you two, your teacher said it's not fine, you need to spell out. Then no choice. You have to follow your teacher. Understand? Okay, so different teacher has different style. Just follow your teacher. So right now, but the properties is always the same. So what is the property? The property is tangent, you need to memorize, is perpendicular. This symbol means is perpendicular to radius. So what does perpendicular means, guys? Very good. So it means that radius and tangent, when they meet, it is 90 degrees. Understand? So what is a radius? So if I have a circle, remember radius is always from the center to the circumference. Correct or not? So tangent means just nice touching the circle at one point. Do you remember we do curve? You all see this keyword called tangent? So remember your curve is here. Where's the tangent? The tangent is just nice touching the curve. Correct or not? So this is also the same thing. What is a tangent? The tangent is just nice touching the curve. Okay, don't want too messy. So I will do highlighting. This is tangent. Okay, no, wrong color. Shouldn't use blue the same as this. Use green then. Tangent. So here is my tangent. Okay. Then radius. I'll do it in pink. This is where my radius is. Okay, I'll give you guys some time to copy. And then don't forget your 90 degrees. So your 90 degrees is here. They will meet and give you 90 degrees. So when you use this property, next time, if you want to find this angle, you must say, how come you know it's 90 degrees? Because tangent is perpendicular to radius. Now, the second property, guys, remember radius is this short little one, right? So it's something longer than a radius. Yes, a diameter. So the second one I'm going to teach you guys is called the diameter. Oh dear. Now go to a new page. See. Blank page. Oh no, it becomes at the bottom. I do page break. Okay, never mind. No choice. What if I do all these? Select all these. Paste. No, it's not working. Okay, never mind. This will just be the last page then. Okay, so right now, you'll say number 2, right? So just now we wrote radius is perpendicular to tangent. So number 2, we talk about the diameter. Now, how is diameter being located? You know that diameter, when you see this keyword diameter, is very important, okay? You know why? Later, I'll let you all see some exam questions. They love to test on diameter. So next time I ask you, hey, guys, see diameter, what comes to your mind? You must tell me, oh, Miss Lin, diameter is linked to this property called right angle in semicircle property. So this is the reasoning you need to memorize, okay? So what do I mean by right angle in semicircle? So remember, diameter cuts through the center into 2 equal halves, correct? Your 2 equal halves, this part here is called your what? This is called your semicircle, correct or not? So where does this right angle comes in? Because it will form a triangle right here, 90 degrees. So this is where your right angle is. Clear so far? And where's your diameter? So you need to highlight in green. This is where your diameter is. So your diameter will give you a right angle, which is a 90 degrees right here. So next time, wherever you do semicircle or diameter, take note, we'll use this property called right angle in semicircle. So I'll give you guys some time to copy. Now, these two seems very easy, right? Now we'll move on to something more complex. So these are things that I look out for whenever I do circles question, okay? Can you see my whole flow of thoughts? Number 1, I go and find my who first? Radius, correct? Number 2, who do I find next? My diameter. Can you see all these are my flow of thoughts? Because last time I used to give everybody like that. Remember I told you I used to give the notes like that? But right now I revamp the notes. I put it into flow of thoughts. So you know very clearly, step 1, what do I have to do? What do I have to find? Step 2, what I have to do? What do I have to find? Don't forget to color code, super important, okay? Okay, guys, hands down. So right now, number 3, we are going to move on to this thing called the four-sided figure in a circle. So you need to take note that the number 3 I'm going to look for is a what? A what? Guys, come on, respond. Four-sided figure, right? And a four-sided figure that you learn in primary school is called a what, guys? Four-sided figure is called a quadrilateral. And where is it at? It's in a circle, correct or not? So if it's in a circle, that means that it is called a cyclic quadrilateral. Clear so far? So in future, your teacher says cyclic quadrilateral, she just meant a four-sided figure in a circle. So where's a four-sided figure? You need to be very careful. Remember, just now I told you location matters. The four-sided figure must be touching the four corners of a circle. Touches 4 points on the circumference. Understand? Okay? And it cannot cut through the center. It cannot touch the center at all. So, for example, a lot of students are being tricked. Is this, can you use the property for a four-sided figure? Is this considered a four-sided figure in a circle? It can be, but you cannot use the property. Why? Why you cannot use the property? Because who is different? So where's that one of the point? This is wrong. This is not on the circumference. Do you understand now? So whenever you have a four-sided figure in a circle, we use this thing called, the property is called angles in opposite segment. Now, some school teacher, right, are very particular. They don't want you to just write angles in opposite segment. Okay? They want you to write angles in opposite segment. Too huge. Too small. Angles in opposite segment are supplementary. Who remembers what is supplementary? Who remembers what supplementary means? What are supplementary angles? Who remembers what are supplementary angles? What are supplementary angles? Sorry? What? It forms what again? I cannot hear. Yes, very good. Supplementary means 180. So opposite means this one plus this person here will give me how much? 180 degrees. And this person right here in blue plus this person right here in blue will give me 180 degrees. Do you understand now? I'll give you guys some time to copy. Have you all copied the diameter one already? Who haven't copied? Okay, everyone copied. Now move on to this quadrilateral. Now, next we're going to do, looks like a four-sided figure, but it's actually not. And this is also one of my favorite one that I like to use. So after I look at the four-sided figure, the next one, call this thing as the bow tie. Now, I want you guys to draw for me, how do you think a bow tie looks like first before I continue? So go and draw for me over here at the side. How does a bow tie look like to you first before I continue? Otherwise, if let's say, if somebody here do not know as a bow tie, then I cannot use this bow tie technique already. So draw already, let me see. How does a bow tie looks like to you? No need to draw it very 3D, just 2D will do. Okay, let's see. Where? Okay, this one is clearly okay, good. This one also good. No, cannot. I say 2D. Cannot. If you do like that, then cannot. Not really also. This one not really. This one okay. No need so much accessories. Just very clean and simple lines. That's it. Oh no. I think we're gonna have an issue. That's a ribbon. That's not a bow tie. A guy don't wear like that. A guy don't wear a ribbon on his collar. Okay, very good. So everybody has gotten it except one student who's still drawing a ribbon. We're not drawing a ribbon, we're drawing a bow tie. No, this is a candy. It's just very simple lines. That's it. Just using lines. Draw a bow tie. I'm going to give the one last student a chance again to draw a bow tie. So the bow tie technique, guys, while waiting for this last student, you all can write that down, that a bow tie, this is the reasoning you need to memorize. You all can write down in red now while waiting for this last student. No, that's even worse now. It's just lines. Why are you drawing curves? It's just lines. It's just using lines only, straight lines to draw a bow tie. 2D. Yes. So guys, bow tie means it will look like that. Correct? Two triangles. So where are all these bow tie? Okay. So can you see this is your bow tie? I'm going to highlight in pink. This is your bow tie. And touches all 4 points of the circumference. Guys, take note now. So later I want you to go and do this in green, in green, in green, in green. Understand? So this is your bow tie. And take note, can you see that this looks very different from the quadrilateral above? Can you see that? Because this is a very clean, like a four-sided figure. It doesn't crisscross. But this one, they crisscross, correct? So when you use this crisscross method, it's also 1, 2, 3, 4. They all touch on the circumference. But it's a crisscross compared to version 3. Understand? So in this bow tie technique, whenever you use this bow tie technique, the reason you need to give is called angles in the same segment. So what do you mean by angles in the same segment? Segment, okay, that means that in order to use this, That means that this angle right here and this angle here will be the same. Okay? And after that, we'll change color. I'll change to blue. This angle right here and this angle right here will be the same. Can I say that this angle and this angle are the same? Yes or no? No, they are not the same. Okay? Only the tip of the bow tie and the bottom of the bow tie will be the same. But these two are not the same. Clear so far? Now you can make your notes. So I better put in some numbers so that you are clearer. So let's say, for example, this is 20 degrees. Means this is 20 degrees. And if this is 40 degrees in blue, that means that this is 40 degrees. I think with numbers like that, you'll be a lot clearer. Okay, that the top bow tie is the same as the bottom bow tie. Now, guys, can you see this new one that I just drew? Right? Now, this new one I drew, can I use the bow tie technique? Yes or no? Huh? Cannot, right? Why? Why cannot? Because of this particular point. This particular point is not, because this particular point is not on the circumference. So can I use the bow tie technique? Even though, yes, Miss Lin, it looks like a bow tie, but almost everything is touching. But can I use it? No, I cannot. Because of that one particular point. Just because of that one particular point, I cannot use this strategy already. Do you understand? So that's why it's very location sensitive. Understand now? What do I mean by location? It's very location sensitive. Okay, so I teach this chapter a little bit different from a lot of teachers in school or in tuition centers because I realize students struggle to identify. Later, right, I'll show you a very typical O-level question. It's very simple, but a lot of students just cannot do. Why? Because they are not location sensitive. Understand? So I revamped this whole notes. It's no longer like that because this is what you're going to get in school also. No point. I teach you what is the proper flow and how to be location sensitive. Then with that, I think you all should be really good in this chapter. And this chapter, guys, is worth about 7 to 12 marks. It's another like graph question. Usually it's in paper 2. Understand? So if you master this, and remember the graph that even though your exam wasn't tested, I made you all do again. Remember the graph plotting? Once you master these two, right, easily you can get 10 to 20 marks already for your exam. Okay? You'll be guaranteed at least an A1 if you do the rest properly. These are the two main big ones that always affect students to get their A1. It's graph plotting and circle. And guys, this circle, right, I'm combining 2 chapters into one today. So today is a lot of massive learning. Clear so far? Then next week, we're going to apply to the exam question. So remember the whole set of exam papers that you guys have? You all bring today? You all bring, right? Later, I'm going to take out one question we're going to do from there, okay? All right. So guys, have you all copied number 4 already? Now, number 5 is something that a lot of students cannot master. So I'm going to teach you number 5 and how to do it properly. Then after that, I'm going to do number 6. So number 6 is specifically only for Hong Yun. We'll do that, okay? So bear with me. You also can write down, but you guys cannot apply it because number 6 is for a math student. So Hong Yun, I just teach you because you will need it. All right? Okay, so number 5, let's go. Now, what is number 5? Okay, number 5 is a really long reasoning. It's when you see location like it involves center plus circumference location. Now, when you see something that involves a center and a circumference location, there is this reasoning that you can give. And the reasoning is also really long. Okay, so what is the reasoning? The reasoning is angle at center is equal to 2 times the angle at circumference. Now, some teacher want you to spell 2 and times, okay? But for me, just like that is enough. Angle at center is equal to 2 times angle at circumference. I'll give you some time to copy first. Then I'm also going to teach you all the strategy. What is the strategy I use? This strategy is only something that you guys in Math Munchies will understand, okay? Your friends or teachers will never understand. But it's important for you to understand so you can identify. Okay, once you're ready, you can draw your 4 circles. Center is in pink. So use your pink pen to mark out the center. The center. So use your pink pen to mark out all the centers. And then circumference is in green. You can use your green pen to mark out the circumference. Oh no, this one is bad. I'll mark it out here instead. Okay? So once you're ready, so this one is the center. I don't think you can see properly. These are all the centers in pink. So the centers are all in pink. Don't forget to highlight this in pink and highlight this in green. Okay, so right now, let's continue. Now, remember just now, I taught you guys about the bow tie strategy. Then after that, we say that this person is not at the circumference, so we cannot use, right? So please take note that this is not using the bow tie method. Okay? So now, how do we go about finding? So technically, do not be confused between this and the bow tie. Because why? Can you see now it involves a center? So the one at the center, okay, so that means that this person, the one at the center, will be 2 times the one at the circumference. So if let's say, for example, this angle right here is 10 degrees, that means that this angle here is how much? 20 degrees. You understand right now? Now, and what do I mean by smiley face with smiley face? So can you see that this curve here, is it upwards or downwards? Upwards. So this is a smiley face, correct? And this one is upwards or downwards? Upwards also. So can you see these are 2 smiley face? It can work. So it means that when you apply, it's the 2 smiley face technique. Got it? I'll give you guys some time to copy. Now, one more about this strategy is, okay, write down this hint. Start from circumference to determine center. Okay, write that down. Hint. Start from circumference to determine center. So guys, can you see here, the next one? Can you see at the center, it has one angle here and one angle here? Correct or not, guys? So which one do you think I should be focusing? The sad face or the smiley face? The upwards or the downwards one? This is downwards, this is upwards. Which one should I be focusing on? Upwards or downwards? Upwards. Why? Because remember I told you guys, you must look at the which one first? The circumference first, right? So can you see here, the one at the circumference here will match with this person. Understand? So if this person here is 20 degrees, oh, this one cannot be 20 degrees. Yeah, can. If this one is 20 degrees, that means that this angle right here is how much? 40 degrees. You see that? Understand right now? Smiley face with smiley face. Now, next. You know what is a common mistake made by a lot of students? And I want you all to write this down. So we're going to write it in red pen. So what's a common mistake? A lot of students thought that, oh, this one is with, no. This one is with this angle. So if this angle is 100 degrees, that means that this angle here is 200 degrees. Okay? And this is wrong. Why is it wrong? Because it doesn't define the strategy already. Because the strategy say always start from who? Circumference or center first? Look at the circumference. This circumference here is happy face or sad face? Sad, right? Sad face, right? This one, happy. Can match or not? Cannot. So this is the mistake that a lot of students make. So what is the proper way? The proper way is, I'm going to redraw the same thing again. I have here, right? Oops. This is not very well drawn. Can I let you all make notes first, so I'll try to draw the next one. Okay. So if this is 100, it means that I should be looking at here instead. This will be 200. Okay, so far? Because this is clearly set face. Can you see set face with set face? Set face with set face. Got it? Now, lastly, guys, what do you notice about this person, the one in orange? Nope. Everything is straight line. So the one in orange is a diameter, correct? And remember I told you guys just now, diameter, what happens, guys? What property can you use for a diameter? What's the property you can use for a diameter? Huh? Right angle in what? Cannot be just be right angle. Right angle in semicircle. Can I use for this case? So can I say that this is 90 degrees? Cannot. No, cannot. Why? Because it must be a right angle what? Triangle. Is there any triangle, right angle, triangle? No. So you cannot use this. So this is wrong. Understand? So all the wrong answer must copy. So what is the right way? So this is a diameter. This is the center. So how do you go about doing it? So always look at the here first. Okay, see this angle right here? At the circumference. And this is the angle at the center. So let's say this is 30 degrees. Or this is like 80 degrees, right? Not 80. Let me erase. I don't want 80. 60 then. 60 degrees. So can you see this one is like set face, correct? With this set face, correct or not, guys? So I know that here is 120 degrees. Understand right now? So usually how I identify this, I identify this as the flat pole that cuts the center. I call this as like a flat pole. Why is it a flat? Can you see that this is the flat here? You guys look at the screen. This is where my flat is. Understand? And this is the pole. You know the flat? This is a flat pole. This is the flat. And this is the pole, right? So I'm using this flat pole method. Okay? So the flat pole is actually your diameter. And your flat is this. This is your flat. Flat pole is the one in orange. And the one in green is your flag. Now with that, we are officially done with 5 properties of angles. I want to do number 6 with Hong Yun. So Hong Yun, this one, listen up. The rest you want copy also you can. Okay, so Hong Yun, this one is specifically for you because you need this for emath. So number 6, Hong Yun, is this reasoning that we call is called alternate. So you need to memorize alternate segment theorem. Okay, so what is the alternate segment theorem? An alternate segment theorem involves a triangle. The triangle must all touch the circumference. All the 3 points of the triangle is on the circumference, plus you need a tangent. Okay, Hong Yun? So what does that mean? It means that it is only specifically for emath student. So we have a circle here, triangle. Can you see there's a triangle here? Right? So this is your triangle, touches the circumference. And you need a tangent. I'll change color. The tangent is here. This is where your tangent is. Understand? Clear so far? So now, your tangent, Hong, you need to be very careful is, can you see that at this tangent, only this angle of the triangle is touching the tangent? Fair or not? So this one is where we identify first. Then why is it called alternate segment? Because, can you see this one right here? This purple one? This purple one and this purple, all the way to the tangent, not the arc, okay, Hong Yun? Not here, not up to here, okay? It's all the way until here. These two purple one are the same. So if let's say here is 30 degrees, that means that here is also 30 degrees. Clear so far? And then if let's say here, right here, this is the blue one, this blue will be the same as this blue right here. So if this blue one is 70 degrees, okay, that means that this blue one is 70 degrees. Understand? So that is how you use alternate segment theorem. You use it a lot in Set 4. Yep, so you can make your notes first. So this is called alternate segment theorem. So this one will help you shortcut a lot of things. So the emath student, right, will probably do 4 steps to find it. But for you, you only do 1 step and you get the answer already. So this shortcuts a lot of things. So once you guys are ready, you can take another blank piece of paper to write length properties. Length properties. So we are officially done with angles. We are going to do length properties. Okay, so next one you can write in highlighter in a blank piece of paper. Length properties. Okay, so just now was 1 whole page on angles. Now will be 1 whole page on length. So length properties, this one will benefit a lot for Hong Yun, especially. Okay, so Hong Yun, please take note about this because length properties is something you need it in emath a lot. Okay, so length properties. Number 1, the first length property. Okay, What is the first length property? Is that we need to, before we learn length, there are a few keywords you need to learn. Okay, we need to learn this thing called the chord. So what is a chord? Okay, so a chord you can imagine as this guy had really short bangs. Can you see that? Okay, this guy had a really, really short bang. Then can you see what is this person here? This one is the what, guys? This is the center, right? So we let the center be the nose. So this person is a... Okay? So what is chord? The chord is this line here. So not pink. So this right here is called the C-O-R, C-H-O-R-D, the chord. All right? Do you notice something? It's not a diameter. Why? Did the chord pass through the center? No. So as long as, then another way is you can see it as just a black pen. Okay. So another way you can see as this. This person has a really round belly. Okay? So this is the belly button. And then he wear the pants. The pants, okay? Low waist pants, all right? Like Winnie the Pooh like that. Low waist pants, and that's the leg. So where's the cord? The cord is here. Got it? This line right here is cord. Okay, so you can draw that out to identify what is the cord. And once you identify what is a chord, from there we can do length properties. Oops, this is meant to be in red. So this is the reasoning that you can give to do length properties. This one I'll draw really big. Please try to draw a really big circle. Usually center we represent as O, 0. Okay, guys, pens down. So right now, okay, see I highlight the pink one as chords, right? And the blue one is equidistant. So what does that mean? If this length, guys, if the question say that this length and this length are the same, okay, because sometimes they say that these two are maybe 5 cm. So if these two are 5 cm, I can say that this and this are the same. So can you see I put B, C, D? Right now, guys. So here will be called X. This point here. And this point here can be Y. So I can say therefore OX is equal to OY. When I write like that, I'm not referring to the angle. I'm referring to the what? Huh? What radius? I'm referring to the length. Yes. There's no radius, woman. Radius is from where to where? Guys, radius is from where to where? Circumference to the center. Is OX a radius? Yeah, they're not radius. That's why I tell you location is very important. You cannot anyhow identify, oh, center is radius. No, OX and OY is not radius. No. So guys, where is the radius? Which one is the radius, guys? Which one is the radius? What? What is the radius? Guys, there are radius, but where is the radius? LO? There's no L. There's only A, B, C, D, and X and Y. C, where? Yes, CO is the radius. What else? Any more? DO radius. Any more? OA, OB. And what did I tell you guys? Wherever you have a radius, you need to tiny line, tiny line, tiny line, tiny line. And what happens? What appears? Isosceles. But I won't want to do it for this case. That's why, see, I'm erasing it off. Because don't be confused with this property. If you indicate it inside, you will be confused. Keep it simple. This property is just chords equidistance from the center. Don't go and add in the radius. There's nothing to do with radius. Clear so far? Now we'll move on to number 2. Okay? Number 2 is called the reasoning. Your red pen, you write it down. The reasoning is called perpendicular bisector of chord. Guys, perpendicular means what? Links to what? 90 degrees. What about bisector that you learn in coordinate geometry? Links to what keyword? Bisector links to what keyword they learn in coordinate geometry? Bisector. What does bisector means? What does bisector means? They learn in coordinate geometry. What would bisector means? What does bisector means? Middle. Yes, in coordinate geometry, what keyword did we learn about middle? There's this particular keyword that you learn in coordinate geometry that links to middle. What is the keyword? I don't see anyone taking out coordinate geometry notes. I don't see anyone participating. I don't see anyone flipping through the notes. Guys, you need to be active learners. Sec 3 already. Have to be active learners. No, intersect doesn't link to the middle. There is a keyword that you learn in coordinate geometry that links to middle. Bisector, you say middle. What keyword is it? that you need it from coordinate geometry. No. Intersection doesn't mean it's middle. Doesn't mean intersect means middle. Hmm? Where do you find it? So what is linked to middle? Huh? What? Midpoint is linked to your coordinate geometry. So midpoint is your middle. So perpendicular bisector means this right here is your perpendicular bisector. And your perpendicular bisector, what your perpendicular bisector will do? Your perpendicular bisector will do two things. What are the two things your perpendicular bisector will do? Huh, guys? Number one, 90 degrees. So 90 degrees is here, number one. And what else? Huh? The answer is just literally on the screen. Just need to read out. That's it. What's number two? Exactly. Midpoint. So this is number two. So midpoint means where? Means what about this particular dot right here? Midpoint means it's in the middle. So what does that mean? So you have A, O, X, and B. So what does that mean, guys? If let's say if it's in the middle, I can say that. What about the length? Yes, I can say that length X. Yes, very good. Length AX is equal to length XB. And what else can I say that can also use for angles property? So this is length, right? But what about angles property? What about for angles property? What can I say? For angles property, what can I say? I also can use this for angles property. What can I say for angles? Angle what? OX B, yeah, equal to angle what? OXA. Cannot stop there. Continue. Equal to 90 degrees. And how do I know it's 90 degrees? What's the reasoning that I have to give? What's the reasoning I have to give? The answer is literally on the screen. What's the reasoning I have to give? Huh? Yes, perpendicular what? Bisector of chord. And that is how I give the reasoning. So I can also use for angles. So this one can kill two birds in one stone. I can use for angles. I also can use for length. Okay, guys. Next, we're going to learn this property called tangent from external point, okay? So guys, look here. I can see some people writing, pens down. Very important. This is in blue. Where's the external point? This is the external point. And remember just now, we learned about tangent. The tangent is in pink. How many tangents do you see? There are 1 and 2. Now, what else do you see beside tangent, beside external point? How many radius? 1 radius right here. 2 radius right here. These are your radius. Does anybody remember any properties that we learned? There's no such thing called tangent equal radius. Yes, tangent is perpendicular to radius. So remember just now, the very first property that we learned about tangent and radius, they will give you what? 90. So this one has nothing to do with tangent from external point. If you know that it's because the reasoning is tangent perpendicular to radius. Correct now, guys? So this one has nothing to do with point number 3. Now, how to use tangent from external point is that there's this particular line right here. Okay? So tangent from external point is, remember just now I told you, wherever you see radius, what must you do? Girls, focus. Whenever you see radius, what must you do? Very good. Draw tiny line. Correct? So I can see that this line is equal to this line. And this is right angle, correct or not? Which topic does this remind you of? No, doesn't. Trigo, no. Radius, the other one also got radius, 90 degree. The other one also got 90 degree. What topic does this remind you of? There's this particular topic that it reminds you of. Very close. What topic? Yes, congruency. What do you notice about the two triangles? What do you notice about the two triangles? Very good. They are congruent. Are they similar? Yes or no? No, they are not similar. They are congruent. Because this is a common side. Here 90, here 90, same length. This is congruent. Do you understand now? So this is linked to congruency. So you notice your teacher can actually combine congruence and similarity into this question also. Clear so far? Your teacher also can combine trigonometry into this question also. So technically, this number 3, if come on your exam, you need to be very good in 3 topics. You need to be good in your congruence and similarity. You need to be good in your trigonometry. You need to be good in your circus property. These are the 3 big topics in set 3. You must master. Because you cannot master, you cannot go to set 4. Set 4 is everything about congruence and similarity. It's everything about trigo. It's everything about circles. Understand? So that's why whatever you learn in set 3 is very, very important. It's the fundamental for your set 4. So because I know that it's congruent, I can say that there are 2 congruent triangles. Right now, guys? So 2 congruent triangles means what can I say about this angle and this angle? Huh? These 2 angles are the same. So I will label them. Give me label. I'll call this as O. Here is X. Here is Y. And here is A. So therefore, I can say that angle what, guys? Is equal to angle OAX. And because I know that it's congruent triangle, I can also say that what? What else can I say? This is number 1 that I can say. What else? I can say number 2 also. What else can I say? What about the length? AX is equal to AY. Yes, with that you can make your notes. And with that, I'm officially done with 1 chapter of circles. And we will move on to the 2nd chapter. So today, I teach 2 chapters in 1 lesson. Next week, we'll apply everything that we learned. So remember to bring all these notes for next week. Very, very important. We'll apply all this. So guys, everybody will have the same notes, right? You all know what will happen next lesson? Your homework is to go and memorize everything because, you know, whatever that I write there, I will blank out. You got to fill in the blanks. You must get 100% for next lesson. Understand? So what's your homework, guys? Yes, memorize. You must get 100% for the test. Otherwise, you need to stay back for a retest. Okay? So homework is very simple, just to memorize only. So for example, how will I test you? Maybe I'll give you an example, guys. Okay, I will probably like blank out here like that. So it's 2 blank triangle. Then you need to write the keyword is called congruent. Then I'll blank out this whole thing. I'll give you a diagram. You need to tell me, based on this diagram, the reasoning is tangent from external point. You need to fill in the blanks. Then maybe I blank out here. Then you need to fill in. Then maybe I blank out here. You need to fill in. Understand? Because you all will have exactly the same notes. Everybody should have that. I also have the same notes, you guys. So I'll just blank out and then you guys will fill in the blanks. Got it? Can? Then maybe I'll blank out here. I'll blank out this. Then you need to go and write down what is this representing. You need to be radius. Okay? So just go and memorize all those. You need 100%. Otherwise, you need to study again. Then you need retest and retest and retest until you get 100%. All right, so let's move on to the very last chapter already, and then we're done for today. So you can take out, if you can flip behind, if behind is blank, you can write that down. So right now, we went through angles, right? And then we went through length, correct or not? So the third one we are going to do is called area and perimeter. So I repeat again, the first one what we do what? Angle. The second one we do length. And the third one we're going to do area and perimeter. Okay? Oh dear. I have not enough. Let's see. Okay, so you can write down the heading. It's called area and perimeter. Now, before I move on to area and perimeter, there are 2 things I want to do. Okay, so this one will benefit Hong Yun. Hong Yun already kind of know already. But unfortunately for you guys, it will not come as natural to you as for Hong Yun. So you need to memorize also, okay? But last time when Hong Yun learned this, it wasn't natural for him also. So Hong Yun, you can see emath actually is very beneficial. It's like a stepping stone from emath. Okay, so what is area and perimeter? Let's go back to premise 6. In primary 6, we learn about circles, area and perimeter, correct or not? What's the formula of an area or circle that you learn in primary 6? Very good. Pi r squared. And then what do we learn to find circumference? What is the formula? Pi d. And what is d representing? Diameter. Okay? So this is what we learned in primary 6. Next up, we're going to learn, another thing you need to learn is conversion. So this one, Hong Yun will answer for you guys because he already did that already. Conversion, we are going to convert from degree to radian and radian to degree. So that means, guys, in your calculator, if you put the wrong mode, this whole question is 0 marks really. Your calculator, you need to be very, very careful. You need to put in the right mode. Degree is degree, radian is radian. Understand, guys? So, Hong Yun, what do you learn about the conversion between degree and radian? It's not called 1 radian. 1 something radian. 1 pi radian, yes. Is 180 degrees. So what does that mean? You need to go and memorize this. Understand? Once you memorize this, a lot will be easier on how to convert. So I give you guys some time to copy first. Okay, so right now, guys, if I know that 1 pi radian is 180 degrees, so the question is asking for 2.7 radian, how many degrees? So guys, 2.7 radian, right? Correct, guys? 2.7 radian. Does the 2.7 have a pi in it? Yes or no? No, So where do I put my 2.7 radian? On the left-hand side or on the right-hand side? Left-hand side or right-hand side? Huh? What? Wrong. The left-hand side represents what, guys? Radian. The right-hand side represents degree. So where do I put my 2.7 radian? On the left-hand side or on the right-hand side? Left-hand side. So I put my 2.7 radian here. Correct or not? So if I want to find my question mark, what can I do? Who remembers the technique that I can use? How do I use my secret 7 to find the question mark? Nope, wrong already. That's not how secret 7 works. What? 180 degrees? Divide by Huh? No. Divide by too much. Too much. 180 divided by 2. Guys, 180 divided by who? Radian? You mean radian has a value? So I do 180 divided by RAD like that. Does it make sense, guys? What? 180 divided by? I need some more. Count this with pi. 180 divided by 1 pi. Do I need to put radian? No, it doesn't make sense. After that, followed by? No. Times 2.7, yes. Put that in a calculator, and what do you get? 154.6986 blah blah blah. So therefore, what's my answer? Therefore, what's my answer? 154.7 154.7 degrees. What? 1 dp. Very good, you remembered. It's not 3 SF, right? Because why? How come you know it's in 1 dp? Degree. So you cannot put into 3 SF. Okay? So that is number 1 conversion. Now the next question. So the next question that your teacher can ask you is, in terms of pi, 100 degrees is equal to how many radian? So this is a mistake that a lot of students make. So the default also the same thing. What do we have to start off with? 1 pi radian. Knock, guys. 180 degrees. Now, what clue did they give me? What's the number that they give me? 100 degrees, right? So where do I put my 100 degrees? On the left or on the right? So I put my 100 degrees here. And this is my question mark. So how do I find my question mark? What do I have to do? So what do I have to do? What? If you put pi, then you say what? Over 180 times 100, you can say bye-bye to your 1 mark. Wrong. You will never get this. You'll be wrong. So what is the correct answer? One pi is the same as pi. Still wrong. 1 pi is the same as pi, so it will still be wrong. No, wrong already. Sorry? Very good. 1 divided by 180. Over 100, wrong. What? Times, yes. Times what? 100. This is correct. Then put it in your calculator. And what's the answer? 5/9. So therefore, what's my answer? 5/9. If your answer is 5/9, it's wrong. You need a pi. You can put a pi in the middle. And that will be correct. So a lot of students, this kind of question, it looks very simple, but they will get it wrong. Okay? I think I better put the wrong answer. Because I believe someone here is going to make that mistake. So these two answers are wrong. You cannot have these two answers. Totally wrong. So you need to learn about conversion. Next up, I'll teach you two others. Then I'll teach you a formula. And then we are officially done with 2 chapters already of circles. Remember to write the wrong answer because someone here is going to make the mistake. Okay, so the next one, what do I want to teach you guys? The next one I want to teach you guys is the difference between a segment versus a sector. Okay? So a segment, you can treat it as Winnie the Pooh. Do you all know what's Winnie the Pooh? What do you notice? How does Winnie the Pooh look like? Huh? How does Winnie the Pooh look like? What's so special about this bear? How does the bear look like? What's so special about Winnie the Pooh? Fat, right? Why? Because Winnie the Pooh has a very big what? Stomach. So Winnie the Pooh is yellow in color. What color is Winnie the Pooh pants? Red. Okay. So Winnie the Pooh pants is red. This is Winnie the Pooh. Winnie the Pooh is yellow or orange? Yellow. Okay, Winnie the Pooh. Okay, so we focus on Winnie the Pooh's stomach. All right. So Winnie the Pooh, that means that the yellow one is what? The yellow one is actually called the major segment. The Winnie the Pooh stomach is called a major segment. Okay? Yeah. That day my husband said I'm starting to look like Winnie the Pooh. Yeah. Because my head is so small and my pants is so tight. He said, oh my God, you're starting to look like Winnie. Okay. And then this pants right here is called a minor segment. Okay? So major segment and a minor segment. Major means the bigger area. Minor is the smaller area. Then what do you notice about this purple line? This purple line is the what, guys? Chord. C-H-O-R-D. This purple line is called the chord. And the belly button of the Winnie the Pooh is called the center. Okay? So next, we're going to learn sector. Sector is like a pizza. You all know pizza, right, guys? Pizza always cut through the center one, right? So this is your pizza with the macaroni and cheese and whatnot. Okay? So we have this green one here. So this green section is called the, by now y'all should know already, the what? Major what? Segment. Major what? Sector, yes. Okay. And then we have orange. This orange part is called the minor sector. Then what about this purple line here? This purple line is called the what? Radius. Okay, so with that, congratulations, you have mastered segment and sector. The last one is the formulas. And then we're done for today. Okay, where's my Winnie the Pooh? Okay, guys, done? Done with your Winnie the Pooh and your pizza. The very last one is the formulas that you have to know. Let me find a blank page. Okay. Done, huh? Anybody still copying? So right now, these are the formulas you need to know to find area and perimeter. Before you do anything, you need to understand the mode. Degree mode and radian mode. Now, when it's a degree mode, okay? So degree mode, you need to be very careful. I think I better draw out. And be very careful. This formula is not for segment. This formula is for sector. Okay. So when it's degree, this thingy here is called x. All right. This angle right here is called x. So guys, if this angle here is x, that means that this angle here is how much if it's in degree mode? How much is this blue angle here? 360 minus x. Then what about this blue angle here? Very good. 2 pi minus x. It's not 360 minus x anymore. Understand? So radian is very, very tricky. Remember just now we learned 1 pi is 180, correct or not? 1 pi is equal to 180. So I know that 2 pi is 360. So this one you need to memorize. So if you use 180, you cannot use 180. You must use pi. If you want to use 360, you cannot use 360. You need to use 2 pi. So with that, now, how do we go about to find the area? So if you want to find the area is actually the inside, correct or not? So the area of, what kind of sector is this? Huh? Yes, minor. So you need to be very clear. Area of minor sector. And this is AOB. We need to write down AOB. The formula is equal to x out of how much? 360. And then multiply by what is the formula of area that we learned in primary 6? Pi r squared. Got it? Now here, area is also the same thing. Area is inside. But good news for you guys, this area, the formula is given in the formula sheet. Okay? So this is the same thing. Area of minor sector. No. Yes, AOB, the same thing. AOB is equal to half r squared theta. Now I give you guys some time to copy. And what is theta? Theta is your x. The formula sheet won't write x. It's not r squared x. The formula sheet will write theta. Better put here. Once you're done, you can use your green highlighter and highlight the one in green. The one in green is called arc length. And is it minor arc length or major arc length? Okay. So you all can copy that. Minor arc AB, minor arc AB in green. Then make sure that you memorize all this. Next week you have a test. So your homework is just to memorize only. And then fill in the blanks for the test. Got it? That's all for today. The end.